ABC is dilated from center A by a factor not equal to 1 to form triangle AKL. Which of the statements must be true? Select all that apply, which means there's probably going to be more than one. So it says that we have a triangle ABC, so let's draw that out. So we have A, B, C, and it says that it has a scale factor not equal to 1, which can mean that the next one will be bigger, or it could be less than 1, and which means it could be smaller. So let's draw both instances. So I'm going to grab a different color, and we'll say the larger one goes here, because remember we have to use these lines like that. And so let's say this larger one is here, and it is A is still there, B and K go together, so K will be here, and then C and L go together, so here. Well, then let's make a smaller one, which would mean this right here. So somewhere in here. K would be here, L would be here. So ABC is the triangle that has been given, and then we have AKL. It could be smaller, it could be larger. So let's look at these. It says AB and AK lie on the same line. So, or segment AB. So we have segment AB here. Is it on the same line as AK? Either this AK or this AK? Absolutely. So that one will work. Then it says the line containing BC is parallel to the line containing KL. Well, in our last slides, we talked about dilation, and we said that a dilation brings those lines parallel. So if we have AB, then, if we have line BC, then KL is going to be parallel. So that works also. This one says angle ABC is congruent to ACB. They're looking here. ABC is congruent to ACB. Does that tell us anywhere that they are congruent? It just says a triangle. It doesn't say what kind of triangle. It could if it was an equal angular triangle, but we don't know that. It doesn't tell us that. So it says the ones that must be true. So that one doesn't have to be true. Okay, so angle ABC is congruent to angle AKL, which is this one and this one. Since they're corresponding angles, and this is a similarity thing, because when you dilate something, they're similar to each other. And if you remember, similar triangles have the same angles. The insides are the same, outsides are different. So that works. Those angles, K and B, are corresponding. All right, so a triangle ABC is similar to AKL. We just said that. They're a dilation of each other, so they are similar. And then triangle ABC is congruent to AKL. No, because it says it was not equal to 1. If it was equal to 1, they would be the exact same triangle. But it's not equal to 1, so this one doesn't work. The two-way table shows the classification of students in a mathematics class by gender and dominant hand. A student who is ambidextrous uses both hands equally well. So what is the probability that a randomly selected student in the class is female? And then it says, given that the student is right-handed. Remember, given that makes the sample space smaller. It takes away stuff. So given that the student is right-handed, so we're only going to look at right-handed students here. So how many right-handed students are there? There's 23. That is going to be my denominator. And then it says female. So how many females of these right-handed? 12. Is that an option? And it is, but if it were not, see if you could reduce this. Put that in the calculator. 12 divided by 23. Don't hit enter. Hit second PRB, and it reduces that fraction for you. This is the same table as the last question, and it says, this is just a second part of it. It says, one student will be selected at random from the class. Consider the events. X, the selected student is female. Y, the selected student is right-handed. Which statement about events X and Y is true? So A says the events are independent because the number of right-handed students in the class is larger than the number of female students. That's not what independent means. Independent means one doesn't affect the other. So being a female does not affect being right-handed any. So the events are independent because the number of categories for dominant hand is different from the number of categories for gender. Doesn't matter. That's not what that is. The events are not independent because for one of the dominant hand categories, the number of female students is 0. That doesn't matter either. It doesn't affect whether they are right-handed or not. And the events are not independent because the probability of X is not equal to the probability of X given Y. So this one would be that. In this question, we have a spring that is attached on one end to A and one end to B. So here's our spring. All right. And it says that A is a collar and it slides from C to D. Okay, so it's going to stretch or compress this string as it slides. All right, and then we have angle theta here. It says when theta is 28 degrees, so if this was 28 degrees, what would be this distance? So let's draw this out a little bit better, okay? So this is going to be a right angle here. All right, we have 28 degrees here. This right here tells it that this side is 3 feet. Okay, and it is asking when that angle is 28 degrees, how long is this spring? So we're going to use, this is a right angle, we're going to use some trig here. When we have one side of a right triangle and an angle, we use trig. And if you remember, SOHCAHTOA. And so let's look at what sides we have. We know X is our hypotenuse because it's opposite of that right angle. So we have our hypotenuse. So we're either using sine or cosine. And then 3 is adjacent to 28. So we're going to use cosine. So we put cosine of what our degree is, 28, equals what over what? Adjacent over hypotenuse. So 3 over x. And remember, when x is in the denominator, you can just trade places with your trig function in degrees and your x. So we can just put x over here, 3 over cosine of 28. And then once you, and it says to the nearest 10th of a foot. So then remember, it's going to be 1 decimal place past, or so 1 decimal place. So when you put that in your calculator, 3 divided by cosine of 28, you get 3.4 feet. And because it gives you feet, you don't have to write it. So be careful of that. If it gives you what your unit is, just leave it alone. We've got the same setup as the last problem, but in this problem it says when the spring is stretched, the distance from point A to B is 5.2. So we were just finding that, but now we say it's 5.2. And we got to find what this is. So if we drew this out again, Sometimes it's easier to draw it out of what the picture shows. We know this is 3. We know this is 5.2. We don't know what theta is. When we're looking for our answer, when we're looking for an angle, we know we're using that second button on the calculator, okay, because we're trying to find the angle. So we don't know what, and it's the same side, it's adjacent and hypotenuse. So we know that cosine of theta equals 3 over 5.2. When we know what the cosine is, we have to find the angle. So when we use that second button, it does this. This is what it looks like in our calculator. So arc cosine, ARC cosine, or cosine -1 inverse, sometimes it's called also. So you put that in your calculator, and it says to the nearest 10th of a degree. So we'd have 54.8 degrees if you put that in your calculator.